Hello everyone and welcome to today's session, which is a continuation of our previous work. Please don't forget to subscribe for new videos and follow our updates all the time. We are looking at coordinate geometry, and in our previous session we looked at parallel lines. We are going to continue with two more examples regarding parallel lines, and then we can look at perpendicular lines. If we have time, then we also look at the points of intersection. So, like we've seen in these examples, we look at the first example, and it's saying, find the equation of a line joining the point P and Q, and is parallel to the line passing through the point A, which is 1, 1. So the question says, find the equation of a line joining the points P and Q. This means there is a line which joins points P and then Q. So when it joins point P is 4, -2, and then point Q is 3, and then 7. So they still continue and say this same line is parallel to the line passing through the point A, which is that. So there is another line that does not meet with this one since they are parallel. But this one passes through A, which is 1, 1. We can assume it can pass through another point. Let's say it is B and it is X, Y. So these two lines do not meet. This one is going in that direction, and this one is going in that direction. But we say for parallel lines, they've got the same gradient, which means this line has got M1, this one has got M2. But since the two lines are parallel, M1 must be equal to M2. This is the scenario that we always use in comparison of the parallel lines. They have the same gradient, or they have similar gradients. Now, we recall how do we get gradient? Gradient is M given as y2 minus y1 out of x2 minus x1. What we call the change in the y values divided by the change in the x values. Now, when I look at my two lines, I have line joining P to Q. It is with two known points. This one joining A, let's assume to be, it is with one known point. Now, a line with one known point cannot give us a gradient, but a line with two known points can always give us a gradient. For example, we have line coming from P to Q. It has got known points which are P and Q, all having coordinates, which means these are known points, and so we can assume that this is my x1, this is my y1, this is my x2, and this can be my y2, which means I can substitute and I say my m is going to be given by, when is my y2? My y2 is 7 minus my y1, which is a -2, divided by my x2, which is a 3, minus x1, which is a 4. So my gradient is going to be 7 minus -2. This becomes a plus, so this is 9. So this is 3 minus 4, which is a -1. So from here, when we divide, the result is going to be m is equal to -9. So that is the value of m. And getting the value of m from here, that means our m1 is -9, and that makes our m2 also be -9. But recall, we are finding the equation of this line. And so we now know its point and we know its gradient. So I can easily recall that y is equal to mx plus c. I recall that as the general equation of the line. And so from here I can easily substitute and I say my y is equal to -9x plus c. But I'm focusing on this line because I need to get its equation, which means I'm going to use using point A, which is 1, 1. I can come and say 1 because this is x and this is y. It's equal to -9 times 1 plus c. So 1 is equal to -9 plus c. So my c is equal to 1 plus 9, making my c to be 10. So if my value of c is 10 and we've got it, this means that we can assemble and come up with the equation of the line. And so since it is y equals to mx plus c, this means that my y is -9x plus a 10, which is the value of c. So that becomes our equation of the line, or the equation of the second line as requested in our previous question. So we look at the question, this is what it wanted, and this goes for 4 marks in your exams. Okay? That is question 1. So when we go to question 2, we can also look at a question set in this form, where they say find the equation of a line passing through the origin. We know the origin, and we say the origin is a point with the coordinates 0, 0. That is what we call the origin, or is denoted with the point 0, 0. So they want me to find the equation of the line passing through the origin, and it is parallel to the line, and this line does not meet another line, but the line it does not meet, the line is given in form of its equation 3x plus 2y minus 4 is equal to 0, is equal to 0. That is the equation of the second line. Now, from the equations of the lines, you can always look at, remember we say parallel lines. What is common with parallel lines? If line 1 has gradient m1, the second one will have gradient m2. But gradients in parallel lines, m1 must be equal to m2. Parallel lines have got the same gradient. So from this line, which is given in the form 3x plus 2y minus 4 equals to 0, we need to get the gradient m2 from here in order to compare it with m1. But we cannot get m2 if we do not rearrange this equation. Remember we said the equation is given in the form y equals to mx plus c. What does this mean? Y must be a subject of this. It must be a subject of the formula. And that means I'll have to take the rest this side. So it will be 2y is equal to, when 4 crosses to come this side, it becomes a 4, then minus the 3x. But still, y is not the subject, which means I can divide by 2, divided by 2, divided by 2. And so my y is going to be 2 minus 3 out of 2x. In rearranging, this is the same as y is equal to c plus mx. So when I compare, the value of m2 will be negative 3 out of 2. And what does this mean? The value of m2 at the same time is the value of m1, which means m2 is equal to m1, which is equal to negative 3 out of 2. And so the gradient of this line is the gradient of this line, and both gradients will be negative 3 out of 2. And this one is also negative 3 out of 2. So after getting the gradients, and we know the point where this line passes, we can easily come up with the equation of our line, and it is always very simple if we calculate it. Let's clean here very fast and finish that before we look at perpendicular lines very fast. So when we look at this as the continuation from here, we've got the gradient m1 and m2, and the two are equal. So we need to look at a line which is passing through the origin, point with 0, 0, and has got a gradient which is given as negative 3 out of 2. Knowing that it is y equals to mx plus c, the general form, when I try to get the value of c, I will have my y is equal to negative 3 out of 2x plus c. So I'm going to substitute for x and y, which are the values here from the known point. So 0 is equal to anything multiplying 0 must give us 0, then plus c, so meaning our c is 0. And so in the forming this up to get the general equation of this second line, it will be y is equal to mx plus c, and so y is going to be equal to negative 3 out of 2x. That is the equation of the line passing through the origin as it has been requested by our team.